In this video, we're going to be looking at simplifying radical expressions. To do this, there's a couple of laws that we need to know. These laws hold for all positive values. So, if n is our index and we have a product underneath the radical, then we can separate that product out into the product of radicals. And that's what number 1 is doing. Number 2 says if you have a fraction, then you can split the fraction. This is very much the same as the product to a power in exponents, where you're multiplying two things. You have an exponent. I call it distributing the exponent because it looks like that. However, what we're really doing is something different, and the effect is that it looks like it gets distributed. So this is analogous to what we're talking about for the radical expressions. We're going to use both of these in conjunction with one another to simplify this next radical expression. Now I've got a list of steps in front of me, and I'll read them to you as I go through. Step 1, identify your index. And so we're just going to write down what our index is. This is going to kind of keep our brain focused on the number 4. In step 2, we're going to try to simplify this fraction underneath. If you don't have a fraction, you can obviously skip this step. But I'm going to pull the fraction out and take a look at it separately because I'm more familiar with fractions than I am with radicals. And so 256y to the 7th. Okay, in order to simplify this, I need to find the greatest common divisor. And so I'm looking for the greatest common divisor of 80, the other 80, 80, and 256. Now, you can do this on a calculator. Right now I have the TI-83 up and running. And so what I'm going to do then is I'm going to go to Math. By the way, the same keystrokes are for the 84, all of the 84s. It might be a little different for the 83 without the plus. But you go to Math, scroll over to Num, and option 9 is what you're looking for, the GCD. You can either press 9 or you can just select it using your scroll buttons and press Enter. Now we want to find the greatest common divisor of 80, commas are right above the 7, and 256. I always recommend closing the parentheses. And it's 16. So we can just carry that down there. So now I can go ahead and divide out 16 from both top and bottom. When I do that, the effect is I'm canceling a factor of 16 top and bottom. It's going to give me 5x to the 6 divided by 16y to the 7. This is my new fraction underneath the radical sign. So that's going to be my new radicand. Now, I couldn't cancel anything out in the variables, and so I'm just going to let them be. All right, moving on to step 3. Step 3 is a repeat step. We're going to do this once for the numerator, and then we're going to come down and we're going to repeat it again for the denominator. But I try to move things in small chunks. It keeps me sane. So let's start with the numerator. Try to find a factor of the number and variables that is a perfect index value. And remember, our index value is 4, so we want to look for perfect fourth powers. And so we're just going to consider 5x to the 6th. And we're going to ask ourselves, are there any is 5 a perfect fourth power of any number? No, not really, because 1 to the 4th is 1, 2 to the 4th is 16. Well, 5's somewhere in between. The 5 is going to be somewhere between 1 and 2, and so it's not perfect. So that's going to stay put. However, x to the 6th does have a perfect fourth power, and that's x to the 4th. And so I'm going to split x to the 6th into x to the 4th and x squared. Because now I can separate it using number 1. All right, let's go ahead and put the radical back in. So I've got the 4th root of 80 x to the, not 80x to the 6th. We've already fixed that fraction. So let's go ahead and erase that. Well, why are you moving? And we're going to fix that fraction and write in 5x to the 6 divided by 16y to the 7. Now what we're going to do is we're going to split this, and we're going to concentrate on the numerator and denominator. And so I'm going to be doing this in my head. And so here's my fourth root, and then I'm going to be dealing with 16y to the 7th later. But for right now, I'm going to be dealing with changing this 5x to the 6th into 5 times x to the 4th times x squared. When I do that, I can use number 1 to bring it out. And just to give you an idea of what number 1 says again, if I have a product underneath the radical, I can bring that out in front, or I can separate them. Well, I can only bring out something that's in groups of 4, and so I can bring out this x to the 4th, and so that's what I'm going to do. This is going to give me the 4th root of x to the 4th. I'm going to put a division bar here, and there's going to be something else that goes here later. But that's going to be times, underneath that 4th root again, I still have 5x squared there. I can't pull any more powers of 4 out from the top, and so I'm just going to let it be. All right, that's step 3. Step 4 says use equation 1, and that's our product of powers, to bring out the product. And so I've identified it in step 3. And now step 4 is just this piece right here. This is step 4. Step 5 says move to the denominator and repeat 3 and 4 as needed. Okay, so I'm going to change colors here on 3. This is 3, second time. And now we're going to be concentrating on the denominator. So I'm going to bring back my step 4, which is the 4th root of x to the 4th. And now I'm going to be putting something else underneath there. I'm just going to rewrite my top, 5x squared. But now underneath, I'm looking at 16y to the 7th. And the question is, do I have a perfect 4th power? Remember, I'm always referring back to the index. Is 16 a perfect 4th? And it turns out to be true. It is. This is 2 to the 4th. And then y has a perfect 4th power. It's y to the 7th has a perfect 4th power of y to the 4th. And then I have y to the 3rd left over. This is what I can bring out. And so I'm going to bring that out front. Change this back to purple here. And this is going to be under the 4th power of 2 to the 4th times under the 4th root y to the 4th. And then whatever's left goes back underneath. Okay, so this again, this is step 4. We're just bringing it out. All of these steps kind of flow together. But now that I have this, I need to actually reduce it. And so you can pull out the fraction. This is very much like when you're trying to reduce a fraction. You can pull out the things that are going to be reduced and then reduce them by cancellation. I find it easier to pull these out and take a look at them first until you really get comfortable with this stuff. And so the 4th root of x to the 4th is simply going to be x. The 4th root of 2 to the 4th is simply 2. And the 4th root of y to the 4th is simply going to be y. The assumption here is that we started out with positive numbers to begin with. And I know I'm probably going to get some flack for that, but the proper thing to do would be put absolute values around the variables. But I'm going to assume that we started out with positive numbers to begin with. Okay, so now I'm going to rewrite this first chunk here. And so I'm going to rewrite this as x divided by 2y times whatever's left stays put. Under the 4th root, I have 5x squared divided by y cubed. This is our final answer. Now, we can do some things to check, and I basically do three things whenever I check this. First thing I look at, the constants in the numerator and denominator don't have any factors that match your numbers in the index power column. Okay, this is if I tell my students to make columns going from the first power, second power, third power, fourth power, fifth power. Okay, and so they go up to 15 for first and second power, up to 10 for third, and up to 5 for 4 and 5. That way they have something to look at. And so what you're really going to do is you're going to say, are there any numbers in here that are perfect fourth powers? Well, 5's not a perfect fourth power because it's somewhere between 1 and 2. X to the second is not perfect, and now there's y to the third, so we're done there. We're good. We checked. There's none that are perfect fourth powers. The second thing that I do is check the exponents on your variables to make sure they're smaller than your index. Well, the exponents on the variables are 2 and 3, and both are smaller than 4. If they're not smaller, that means you didn't take out enough to begin with. So you'd have to take out another group of 4. For part C, or for the third one, I do the fraction in the radicand and outside the radical are in simplest forms. Basically, this is I didn't do step 2 right and simplify it. And so I'm checking that. Well, I can't cancel anything out in front. I can't cancel anything from that fraction out in front, and there's nothing to cancel within, and so I'm done. This is my answer.